Hello everyone and welcome back to the AWS Solution Architect Associate series. Today we enter the domain 2 design resilient architectures, and our focus is on a very important topic, which is designing scalable and loosely coupled architectures. This domain introduces the concepts that directly impact the reliability, performance and cost of cloud applications. We will look at the microservices, event-driven architecture, queues, pub-sub messaging, scaling patterns, caching strategies, and when to choose the serverless containers or the traditional compute. Let's dive right into the building modern, scalable, cloud-native architectures on AWS. A loosely coupled architecture is one where the application components operate independently without requiring the tight coordination. Instead of directly depending on each other, components communicate through messaging systems, APIs, or the events. So, why is this important? Because loosely coupling improves the reliability. Which is a failure in one part won't take down your entire system. It also improves the scalability since each microservice or the workload can scale independently. This concept is foundational for microservices, serverless architectures, and event-driven applications on AWS. In a monolithic architecture, all functionality is bundled together. Scaling requires scaling everything, that is, even features that don't need it. Deployments become slow and failures become the entire systems. It affects the entire systems. Microservices break the applications into smaller independent services. Each service can deploy independently, scale independently, fail independently, etc. Use the best suited database or the storage. AWS recommends designing the stateless microservices whenever possible. A stateless service does not rely on local session data, making it easier to scale horizontally and run across multiple availability zones. Amazon SQS is one of the key services for creating the loosely coupled architectures. Producers send messages to the queue and consumer process those messages asynchronously. Neither side knows anything about the other. SQS also helps in absorbing the traffic spikes and preventing the overloads, enable the retries, improve the resilience. SQS queues are used heavily in decoupled microservice pipelines, background job processings, and asynchronous workflows. While SQS handles point-to-point messaging, Amazon SNS enables the publish-subscribe pattern. One message can be broadcast to many subscribers such as SQS queues, Lambda functions, HTTP endpoints, or mobile devices. This is either for fan-out scenarios like parallel processing, real-time alerts, microservice communications, or system-wide notifications. SNS plus SQS is a powerful combination for distributed event-driven designs. Event-driven architecture allows the workloads to react the events instead of constantly running. AWS Lambda integrates deeply with S3 events, DynamoDB streams, API gateways, EventBridge, SQL SNS, etc. EventBridge acts like a central events router, connecting services and SaaS applications with rule-based message routing. This approach leads to highly scalable, loosely coupled pipelines that grow and shrink automatically with workloads demands. Vertical scaling means upgrading to a bigger instance type. It's simple but limited. Horizontal scaling means adding more instances behind a load balancer. It's the preferred approach on AWS because it enables the fault tolerance, high availability, resilience, consistent performance, etc. Auto scaling groups basically adjust the compute capacity based on demand. This is why stateless workloads are so important. They scale horizontally without effort. CloudFront improves the application performance by caching the content at AWS edge locations around the world. It reduces load on your origin servers and delivers the lower latency to users globally. Typical use cases include web applications, static frontends, video delivery, API acceleration, etc. Using edge caching is a key strategy for building scalable architectures. Caching improves performance and reduces load on databases or the application servers. AWS provides two major caching options. One is ElastiCache, that is Redis memcached, which is ideal for storage, session storage, leaderboards, or the caching the heavy queries, etc. And the second one is DynamoDB DAX, which is a highly optimized in-memory cache for DynamoDB. Caching is critical for scalable architectures because it reduces the repeated work and dramatically speeds up read-heavy workloads. When designing scalable architectures, choosing the right compute model is crucial. Use containers when you need to long running applications, you require more control over the runtime, or you are migrating legacy applications. And use serverless when the workloads are event driven, traffic is unpredictable, you want to pay only for the execution time, etc. AWS Fargate eliminates the server management for containers while ECS and EKS handle the orchestration at scale. A multi-tier architecture separates the workloads into independent layers, each with its own scaling and security characteristics. A typical three-tier setup includes presentation layer, which is UI, API gateway, and CloudFront. The application layer, which is EC2, ECS, and Lambda. And the third one is data layer, which is RDS, DynamoDB, or the ElastiCache. Each tier can be deployed, scaled, and secured independently, which is crucial for building resilient systems on AWS. Step functions allow you to build complex workflows with automatic retries, error handling, parallel execution, and visual state management. They are ideal for order processing, data pipelines, background workflows, and the machine learning automation, etc. They remove the orchestration logic from your application code and then make the workflow scalable and reliable. So to summarize, in this video we explored how to design the scalable and loosely coupled architectures using AWS services. We covered the microservices, queues, pub/sub messaging, event-driven design, caching scaling strategies, containers, serverless, and workflow orchestration. These concepts are critical for designing resilient cloud-native applications. In the next video, we will continue domain 2 with designing the highly available and fault-tolerant architecture, where we will dive into the multi-AZ, multi-region disaster recovery strategies, also the RTO, RPO, and failover mechanisms. If this video helped you, don't forget to like, subscribe, and share. I will see you in the next session. Thank you.